Who else? Are you going to send Okay. That's right. The link. Okay. You didn't give them the. Are you not a seminar group? Huh? Never heard of it. No, you is a seminar group.
Who is a class rep? I will share the link to you and you, so that you share it to your respective groups to join. I will share the links to you.
Okay, yes. This is the admin. Okay.
I will share the link to all of you. I will share it. This person will share it.
The project coordinator, Dr. Ahmadu, Dr. Al-Amin, other lecturers, Abdullahi, Hami, and all of them, including the PG students. I welcome you this morning to this short presentation. To start with, this is the outline that I'm going to speak to. We are moving on this mindset. And then I will talk about the components of the good research mindset, which include following serendipity, resources, and modeling. So, as a preamble, I would like to tell you what is the motivation for this topic. Because the topic somehow we look at it like research mindset. What is research mindset? Why do I need to have research mindset? On Monday, Dr. Agungu contacted me that there was a presentation of PG students in which they will be introduced to academic writing, reference, and all that. So I was asked to talk about the academic writing, article writing. Then I said, I think there is something more important than the academic writing, than referencing. There is something that which I consider like a prerequisite to any postgraduate study, and that is the mindset. The mindset forms the very foundation of your postgraduate research pursuit. And I felt like, rather than talking about the academic or article writing, I will talk about the mindset, so that your mind is prepared. We are simply like exploring what do you have, how do you gather the right mindset to pursue postgraduate research. So I framed the topic PG research mindset, and he accepted. And here I am today to present it. Of course, like I mentioned, mindset is a prerequisite in any research. Of course, I will expatiate more as we proceed. Tell you more about the mindset. How do you inculcate and imbibe the right mindset for your academic research, postgraduate for that matter. Next. So love what you do and do what you love. Very important. Now, the objective, perhaps the first one, is to understand the importance of a research mindset. And then the second one is, because I hope at the end of this seminar, having talked about the mindset, I expect each and every one of you to set appropriate research mindset. What are your research goals? What do you want to achieve? Where do you see yourself in the next 2 or 3 years in the world of research? So, I expect each and every one of you at the end of this seminar to, not to write it down, but to have it in your minds that, okay, based on what I have learned this morning, I have set social research mindsets. Next. Now, we will go to the first thing, which is definition of that. What is mindset? Okay? Next. Of course, a person's way of thinking and their opinions. This is the definition from Cambridge Dictionary. Second one, a mental attitude or inclination from Merriam-Webster Dictionary. A mental attitude or inclination. For the the past few days, I have been writing about some psychological articles in psychology about a 6-part series. So when he talked to me, I now thought, what can I say that may have to do with psychology as well as academics? So that was one of the reasons that informed the topic, the research mindset. Because anyone that hears the word mindset, he will know that it has, because by definition, a mental attitude to the origination. Then it has something to do with the psychology, isn't it? The psychology of the mind, the state of the mind. But that state of the mind is what? That's why we said research mindset. We're not really like interested about your personality, who you are. But now we want to explore what mindset, what research mindset do you have? What mental attitude do you have towards research? What are your inclinations toward research? So definitely it is partly a psychological topic, but at the same time, we will explore both the psychological aspect as well as the technical aspect of the topic, which is the research mindset. So from this, now, by definition, mindset is a mental attitude or inclination. Now we can go further. What about now the research mindset? So that can simply be put as your research personality. We all have our different personalities, isn't it? Even if you are twins, okay? Your twin brother will have different set of attitudes, different from yours, isn't it? But that is something else. Of course, it will affect your research personality. But here we want to delve into your research personality. We want to explore it. We want to tell you, okay, how are you going to shape your research personality now that you are a postgraduate student? Of course, I know nowadays postgraduate studies has been turned into more or less like a natural progression from one level, the BS level or the bachelor's level, or undergraduate level to the postgraduate level. Just like someone, let's say in junior secondary school, after JS3 will naturally progress to SS1, isn't it? Without, let's say, any effort or anything special. So nowadays, the students at the postgraduate level are almost, having the same number as that of the undergraduate level. So some consider it as a natural progression from undergraduate to postgraduate, without like giving it a thought, sitting down to think, do I really need a postgraduate degree? Will I truly make a good researcher? Because postgraduate is all about research. If you are not interested in research, please don't go for any postgraduate study. Otherwise, it will not interest you at all. It's all about research. Of course, fortunately, our system is such that even at your undergraduate project, you are involved in some level of research. So it is not something new to you. Okay? So anyone coming to postgraduate should have this mindset. Okay, I want to pursue research. For that, I will do everything possible to make it a success. Because if you don't have this mindset ab initio, you will start, and after some time you will just discard it. You will spend several years without achieving your goal. By and large, it means you have wasted your precious time that you would have spent in doing something more important. So, this is the first mindset that you need to ask yourself. Why am I pursuing these postgraduate studies? Do I even have passion for research? Okay, suppose you don't and you really want, you can still inculcate it. Because, like we mentioned, it's a research personality. Of course, personality, a set of attitude traits and all that, that some may be very rigid, such that we may not be able to change, but there are others that can be a bit flexible, that we can inculcate in ourselves. And we will take each one of these and expatiate more as we progress. So, as I mentioned, can we imbibe good research personality traits? Yes, we can. But we have to identify what are these good research personality traits. Because you cannot, implement something that you don't know. So you need to know them right from the beginning and then try to imbibe them. that will help you in your academic research or in your postgraduate research. Now, next. Components of a good research mindset. The first one, openness. And openness, anyone who knows, however small in psychology, will know is one of the big 5 personality models. Okay? We have openness, we have agreeableness, we have conscientiousness, we have neuroticism, we have extraversion. These are the 5 personality traits that shape each and every part of our attitude. Of course, we have differences. Some will lie high on a particular trait, some will lie low, some will lie in between. But by and large, they are the models that psychologists use to predict. When we say model, sometimes, most of the time, we're talking about prediction. With these traits, you can predict one's behavior, one's mental health, one's physical health, one's success in life, one's interaction with people, both at official level and unofficial level. So it is a deep subject, yet the very foundation of personality psychology. I picked openness because it is central to our discussion today, research personality. Okay, so the others, anybody that is interested can go and explore them. They're very important. We all should know about our psychological traits, each and every one of us. Now, openness, defined as people who tend to be high in the trait of openness are 1, more willing to embrace new things, fresh ideas, and novel experiences. 2, they are open-minded and approach new things with curiosity and tend to seek out novelty. 3, they tend to pursue new adventures, experiences, and creative endeavors. And 4, they are also very good at thinking about and making connections between different concepts and ideas. Definitely anyone that reads this definition of openness will understand why it is central to any postgraduate research. It's all about being novel, fresh ideas, novel experiences, curiosity, creative endeavors, and thinking, connecting different concepts and ideas. So, each of these big 5 personality traits are on a continuum, meaning you have like 2 extreme ends, lower, highest, and in between, okay? So we all fall within this continuum. You can be high on the openness trait, you can be low on the openness trait, but for a good research personality, you should strive to score higher scores on the openness trait. Because as we have seen, it is all about novelty. Research is all about what do you introduce? What do you add to the body of existing knowledge? No matter how small, we are here. Can you take us 1 millimeter away from our current state? 1 millimeter, even if it's 1 micrometer. So it's all about introducing fresh ideas, seeking out novelty, and then, of course, have the capability to correlate concepts and ideas. Like I said, this we need to strive to improve our openness. Of course, some may be low on this, may be low in this trait, meaning they are narrow-minded, rigid, conservative, doesn't want to seek out any novelty. That is a bad trait as far as PG research personality is concerned. Because as we are going to explore further, research is something that you should look at it like, at the beginning you may have some goals and objectives, but you have to be prepared for something that may not be obvious at the beginning. Yet, that thing that may be lurking in the background may be something that will change the course of your research completely, to make it the best, to make you go and earn awards. So that is one of the mindset that we are going to check, which is the next serendipity. Okay, before we look at serendipity, I would like to give some examples of openness, practical examples, because here we're just like talking theory. So I would like to bring an example of something that you all know, you all even know better than I do. Embrace the openness of Elon Musk towards your research. What is his openness? Of course, we all know Elon Musk is the founder or co-founder or whatever it is, SpaceX, Neuralink, Twitter, Tesla, and all that, isn't it? Now, one of his, personality traits is that, which lies within the openness continuum, is about seeing opportunities in obstacles. When he was 12, created a video game, Blaster, about fighting aliens, in space, and all that. Then, with that idea, he proceeded, got his, degree in physics, and then he has a dream. He wants to colonize Mars. Something that everyone will. This guy is crazy. Colonizing Mars. Mars is the fourth planet, isn't it? So how can you colonize Mars that is not habitable? No atmosphere, no water, nothing. And from there, he created SpaceLink, also SpaceX. Started going into satellite. Because to go to Mars, you need rocket, isn't it? You need something to take you there, spaceship or whatever. So he went into now satellites, creating satellites. Now even to go to the International Space Station, the NASA, the National Aeronautics and Space Authority, they are using SpaceX facilities to launch their, astronauts to the International Space Station. Recently, Saudi Arabia, some of their guys came back using the same SpaceX facilities. He has thousands of satellites providing internet. It has come to Nigeria. Starting, isn't it? But his target is not just providing satellite or launching people into International Space Station. It is to go to the Mars. No matter how bizarre that idea appears to us, he still is nurturing that idea. And scientists are beginning to now look at the ways. Some are saying now, okay, we'll have to have some satellites developing around the Mars that will concentrate the light from the sun on the Mars, that will now melt the ice and then introduce microbes that will be producing oxygen. So the journey is still in the process. But in the meantime, he has seen opportunities. He has discovered great opportunities, despite the fact that the mission appears like a failure at the beginning, isn't it? But with that mindset, that openness about creativity, about approaching what appears to be impossible and trying to make it possible, you make the impossible possible. Neuralink. Maybe you don't know about the Neuralink. They want to produce chips that they will implant in people's brain. They want to start curing blindness, hearing losses, paralysis, depression, which is a mental health issue. They want to implant chips and then try to balance the chemicals, monitor the activities and all that. At the beginning, it was impossible. It was like a bizarre idea, just like this one. Because the Federal Food and Drug Agency, the FDA, that regulates all these clinical trials, he was not granted permission. But he didn't give up. He didn't give up, he continued. Now, he got permission to start clinical trials on humans. That is openness, making impossible possible. Why am I telling you all this? You may have an idea, a research idea that you want to pursue. At the beginning, it may appear bizarre. Your supervisor may say, no, you can't do this. If you believe in yourself, then push further. The sky will not be your limit, but it will be your starting point. This is very important. Having good research mindset is very important. Seeking to achieve greatness with your research, despite our limitations in resources and all that. Yeah, I will talk more about that. We have limited resources, no two ways about it. But nevertheless, we have great minds. We can think in innovative ways.
And no matter what little resources that we have, we can still utilize them and do great things. With the little we have, we are getting patents. Why is it? He's in class, okay. He just got a patent. I think it in this month. It's in just this month. He fabricated something, I think from his MSc work, and he got a patent. Someone would expect, no, one, you have to travel abroad before you can be able to come up with some novel ideas. No. He's one of our lecturers, one of our students, and he just got a patent. And of course, we have many others that got patents, whether locally or abroad. You all will probably fabricate or do something novel in one way or another. We all are using materials, not especially those in the environmental area. Materials, is an area that is almost unexhausted. You cannot exhaust it. Okay? You do this, okay, this material has never been used for this. That is innovation. And you can get a patent from that. I'm only starting with a patent. Because from the patent you can get a Nobel Prize, depending on your innovation. It all depends on your imagination. Your power to imagine, your power to explore things. So this is the mindset that we want you to have right from the beginning. Aim to strive to do something novel. Aim to strive, for greatness. And then the sky will be your limit. Forget the fact that we have limited resources. Yeah, we do. But your greatness lies within yourself. With or without resources. Your greatness lies within yourself. You want to be great, you will be. You want to be average, mediocre, or below average, then the path is there for you to follow. Very important. So the mindset, setting the goals, setting your dreams. Dream and dream big. Dream and dream big. Not only dream, but you have to follow it with concrete steps of achieving whatever dream that you have. Next. Now, serendipity. The art of unsought finding. I learned, most of you, that this orientation is meant for. You have finished your first semester, so you haven't started your research. Although I know some have already started, they have gone deep into their research. Prepare your mind for serendipity. In the course of your research, like I started mentioning, you can find some interesting results that can reshape the course of your research, or that can even become like the main goal of your research. Before you start any research, definitely you have your set objectives, goals and all that. But be prepared that you can find some more interesting results that you have never envisaged, that you have never dreamt of. And scientific research is always like that. It's always like that. And when you prepare your mind towards that, once you hit the jackpot, you uncover a very interesting result, then I can tell you that can change the course of history as it has done before. So, by definition, serendipity is the phenomenon of finding interesting and valuable or agreeable things not sought for by chance. Simply accidental findings. Accidental findings. That's why this picture is the art of unsought finding. You are doing something else, and then accidentally you discover something more interesting, more groundbreaking than what you set out to find. Postgraduate research is all about that. Put this at the back of your mind. Look for that jackpot and hit it. You will always find it. Now, I have some few examples to share with you so that I demonstrate exactly the point that I want to portray. I'll start with my serendipitous findings. During my undergraduate project, I set out to apply the Newton law.
Cross method program, a photon program developed by one of the renowned professors of hydraulics, Roland W. Jefferson, to analyze water distribution networks. There are many numerous projects that were done using the same program. So I picked it, started running. Of course, I have to test run it to ascertain its accuracy, despite the fact that many, students have used the program before. But when I test run it, I compared the result with some known results. It didn't give me accurate results. That was not the aim of my project. It wasn't to test run to check the accuracy of the program. It was just out of my curiosity as before I use it, it's a program, I have to ensure that I can get correct result, isn't it? And then I discovered it is not giving me correct result. So my goal has to be now skewed. I now have to analyze that program. What is wrong? I detected 3 mistakes that will make it furnish wrong results. Of course, I contacted him, but then he resigned because he wrote the book in '79. I contacted his university to tell him about what I found, but then whether he knows or he doesn't, now I have to now create my own program, which wasn't what I set out for at the beginning. So I had to come up with my own photon program to do the same pipe network analysis, which is a more difficult and daunting task. But with dedication and God's guidance, I did that. In fact, I published my result in an article, which is another issue that I want to draw your attention to. Some of you doing your master's, postgraduate diploma, or PhD. How many papers did you publish? You have done project. No matter how you look at that project as a non-entity, you can probably at least extract a conference paper out of it. That's the beginning of, reshaping your research personality. Because research is all about publication. After you finish all the bench of the, research, and you have to publish your results. There are conferences and journal articles. Go back, start from what you have. Your projects, undergraduate projects, look at it. Can you extract a journal article? Can you extract at least a conference paper? Start from there. Start learning the art of article writing, very important. It's an art that you cannot learn overnight. You cannot learn it overnight. Extract it, write, take it to your advisor, let him correct you, back and forth, send it, then they will reject, correct, send back to another. It's an art that you need to start learning now. Article writing. Start from your undergraduate work. If you are doing PhD, look at your undergraduate work, look at your MSc thesis. What can you publish from there? Start from there, very important. Now, for my PhD, I was to do, remediation, electrokinetic remediation of a contaminated soil, contaminated using multiple contaminants, heavy metals, trace elements, polar and non-polar organic compounds. But then at the preliminary stage, during the, characterization of the soil, I measured the pH around 9. And then when I checked, it means that the exchangeable sodium percentage is more than 15%. And that makes the soil to become what is called, make the soil to be called sodic, because of the sodium. Okay? It is sodic. And I call the soil sodic soil. I didn't set out to analyze anything called sodic soil. It's a simple Saudi Arabian soil that I set out to just demonstrate the application of a treatment technique using electrokinetic and adsorption. And then you have multiple contaminants, which will introduce a lot of complexity in the decontamination of the soil. Then when I measured the electrical conductivity of the soil, I realized it's more than 4 decimeter, the cesimen per meter, which makes the soil to be called saline. So initially I called the soil sodic soil. Then a step further I realized it is saline, then I call it saline sodic soil. And then that changed the course of my research entirely. Because one, That type of soil was never anticipated for any electrokinetic remediation. And then, of course, it introduced a lot of challenges to the remediation process, which I didn't set out to explore at all. And then the type of the soil turned out to be Montmorillonite, which is swelling again with high electro-osmotic flow. Because in electrokinetics you have like the anolite and catholite, acid and base neutralizing the reactions. So it makes the monitoring, the process and everything extremely challenging. Yet at the end, it becomes highly innovative. Successfully remediated it in the same soil at bench scale and pilot scale. In fact, if not for some glitches that I had, because I filed, my university asked me to file for patent, a US patent. I did. Fortunately, the period, because the US patent has a window, when you publish your result, then you must apply for the patent and get everything done within 2 years. Unfortunately for me, when I finished my PhD, I published even before I defended, and then I started the process. The priority as such was confirmed. The last process was the approval when the 2-year window was reached. So I couldn't get the US patent. But that didn't take away that innovation. It didn't take away the innovation. Yeah, because I didn't have the patent, it didn't take away the innovation that I explored in remediating such soil. So, serendipity. Look out for that. Unsought results. They can change the course of your research. And when you find one, then hammer on it. Hammer on it. There are other serendipities or serendipitous findings. We all know the famous story when Newton was resting in a garden in an afternoon, an apple fell. No, it didn't fall on his head, just saw it falling down. But then he started thinking, it was just by accident. Then he started thinking, why is that everything that goes is like coming down straight to the center of, why is it like not moving sideways? He started to think about gravity. The earth is like pulling things directly towards its center. Now, you continue and came up with the Newton's law of gravitation. We all learned Newton's law of gravitation in secondary school, which forms the basis of, the rotation of planets around the Earth, around the Sun and the cosmic, bodies and all that. But he didn't stop there. While the apple was coming down, he started visualizing. What about the velocity? How is it changing? Is it accelerating? Is the velocity increasing or decreasing? Yes, it is increasing. At what rate? Then he went on to invent calculus. He invented Newton's law of gravity, he invented calculus to try to understand the instantaneous velocity of the apple as it is coming down. Now on the gravity, he started thinking, okay, as it is coming down, it is falling under gravity. What about the rotation of the moon? Is it also like falling towards the earth, but moving in orbit? Then he created what is called a thought experiment. If I throw something, it will come down, isn't it? What about if I increase the velocity? It will still come down, but at longer distance, isn't it? Then he said, the earth is spherical. Is there a velocity that it will like go round? He calculated that velocity as 5 miles per second. And that's the velocity with which the satellites are revolving around the Earth, 5 miles per second. Then he said, what about, is there a velocity that it can escape the gravitational influence of the Earth? He calculated it. He arrived at escape velocity, 7 miles per second, about 11.2 kilometers per second. All these were accidental findings. And of course, even in light, he was just playing with prism, and then there was a ray of light coming through the window. Then he saw the light being splitted into its component colors. So the white light we see has 7 components. And that discovery has changed the course of the world. The world was never the same again. Thereafter, we went to Einstein. My man, black hole, expanding universe. When he set out, to explore the special theory of relativity in 1905, later on he developed the general theory of relativity. He came up with mathematical equations. He didn't set out to find out anything about black hole or expanding universe. He came up with mathematical equations describing his general theory of relativity. And that is where modeling is very important. Mathematical formulation. Based on the interpretation of that equation of the general theory of relativity, he found out that when a star is dying, it reduces to a small size and then become a very high source of gravity that not even light can pass through it. In 1964, a black hole was first detected after he even died. It was a serendipitous finding. He didn't set out to find out about black holes at all. And then from the same equation, he realized that the universe was expanding. Later on, we found out about dark energy, dark matter. The whole energy and matter in the universe, the whole stars, the star system that we have, the planets in the whole universe, they all constitute 4%, which is the non-matter and energy that we have. The 26% is dark matter. That even the physicists did not understand how they behave. The 70% is dark energy, which is causing the expansion of the universe. The physicists are yet to understand them. That's what they call them dark matter and dark energy. We all found them from his serendipitous findings. So, as postgraduate students, brace up. When you undertake some research, be very curious, be very novel, be very attentive, and be looking out for those subtle signs that can change the course of things. And surely, if you are curious enough, you will surely find them. Because there are many other serendipitous findings, many of them that we have. Other serendipitous findings, microwave radioactivity, we all know, Madame Curie, she was just walking and then not knowing Henry Becquerel, isn't it? It was emitting, then he put a photographic film and then accidentally he saw it fall, isn't it? And then from there he realized there would be radiation coming out from this uranium salt that has pierced into this film. So, and we have a lot of other X-rays, vulcanized rubber, Teflon, penicillin, all this. There are many more. Science, research, and serendipity, they go hand in hand. So, as postgraduate students, watch out for serendipitous findings. You will surely find them along your way. When you do, explore them to the fullest. Explore them to the fullest. They can be a source of you getting a patent. Or even better, maybe a Nobel Prize. Who knows? All this, in his, like Einstein, didn't set out to find all these things. But these are things that have changed the course of the world. The world was never the same again. Now, resources. Having set your mind on what you want and your expectations from the research, you need resources. What are the tools? Research cannot be performed in a vacuum, isn't it? You need materials. So excellent articles, books, and theses or dissertations. We start with the articles, which are very important. You have Science Direct and other databases. I want to believe ABU has a subscription to Science Direct.
Yes.
Correct?
Yes.
It's one of the largest repository of excellent articles that ordinarily you have to pay to get the articles. ABU has subscription. You can go and get the login details. I don't know how many for the library or for the PG coordinator, I don't know. But you need excellent, research articles. Of course, there are other sources. You can just Google, and you can have book. But Science Direct articles, you can only see the abstract or some part of it. You have a lot of other good databases, but Science Direct is one of the
richest that we have. Because having excellent research articles is very important. It's very central to executing any meaningful research. Because like I mentioned, research is not like trying to reinvent the wheel. More often than not, it's about taking us, even if it's 1 micrometer from where we currently are. We are here. Can you take us 1 micrometer further? That is how you have to go and find the research gap. The gap. What gap in the literature do you want to fill? What do you want to add to the body of literature? Not just repeating something that someone else has done. You need to be novel, innovative, and creative at the same time. These are the only things that will propel you further. And you cannot do it without, blindly. You need to start from somewhere. Articles are very important. Then you also have books, excellent books, that will demystify certain concepts, certain theories, so that you have the background knowledge. Most of the time when we come during PG seminar, I normally ask basic fundamental questions. You'll finish doing your research, okay, I use electrical resistivity method to determine the depth to aquifer, to water table, this and that. So you will finish telling us all about that, but then I will ask you, can you tell me what is the difference between confined aquifer and unconfined aquifer? This aquifer that you found, that you found, is it confined or unconfined? And then you will see some students, they will begin to be shaking and as if they didn't take them 503. Which is a very basic and fundamental concept in groundwater hydrology. So these fundamental concepts, usually you need excellent textbooks. Excellent textbooks. Of course, we have the library, we have the Kiel, we have the library here, but some of the books may be outdated and the library may not have enough money to buy the best books on the market. But we have some other means. We have Library Genesis. It's a very rich repository of textbooks that is free for you to download. Very excellent textbooks. Excellent. I've been using this for several years. Of course, some talking about, I didn't put the books there. I saw the website, I didn't create it. So when you talk about copyright, yeah, I agree with you, copyright infringement, but I didn't put the test. Whether I download these books or I didn't, it is there. It remains there. So, you want to catch those that, violated the copyright. They are those that created the website. Go and find them. I didn't put the books there. Even when you Google some books on Google, when you Google out some books, you can get some free books even online. So this one I have not, it is the best I have ever seen, sincerely speaking. And if you really want to undertake any good and meaningful research, you need excellent textbooks in that area that will demystify certain concepts, that will make it very understandable. Because understanding the concept is very, very important. I always tell my students sometimes, because I do take a lot of interviews, they will come, vying for professorship position, but we always ask them the basic questions. State Newton's first law of motion, Newton's second law of motion. How do you use Newton's first law of motion to explain statics? Or the basic concept of statics. These are basic things that we took in high school and in secondary school, isn't it? But understanding those fundamental concepts is very important for your research as well as graduation. Very important. Now, we also have dissertations. Apart from textbooks, we have what others have done in form of MSc and PhD theses or dissertations. This is another very good source. Of course, we have our library with all the past projects that we have. But then you can look elsewhere as well. Because you can have something, because in dissertation, it will take you through the process, the literature review, the breakdown of the nitty-gritty. And then from there, you can see some gap that you would like to fill. Because research is all about finding that gap. Like I said, That gap, it may be 1 micrometer, meaning extremely very small. But for a good research, it is expected to fill some gap, no matter how small it is. It is expected to fill some gap in the research literature. That is very important, and that is very critical. Now, during my MSc, one of my mentors, Professor Lumaz Dakar, was in Saudi Arabia at the time. He helped me with some materials for my work. I was assessing the sewerage network in the university, as well as the treatment plant. From the material I received was a thesis on waste stabilization done by Banda in the UK. And that thesis has changed completely my understanding of the system, the process, and has inspired me towards modernism. Just one thesis, which I received from one of my mentors, which I'm going to talk later about mentorship, which is very, very important. Very, very important. You can have one book, one article, one thesis or dissertation that can change the course of your research. You have to look for that. You have to look for that book, you have to look for that article, you have to look for that thesis or dissertation at the right place. And then again, having gone through the system, having understood the importance of all this, I downloaded, because there is ProQuest Dissertations. It's a repository, the database for thesis and dissertations of the top universities across the globe. Of course, like Science Direct, you need subscription. So I had subscription from my university. So I downloaded all the books and all theses and dissertations in different areas of water resources and environmental engineering. Over 2,000 titles. Although I did that about 2016 or 17, since then I didn't update it. But with or without update, the ones that are available, I want to believe they can be of so much help towards your research. They include, like I said, all areas of water resources and environmental engineering. Over 2,000 titles. Over 2,000 titles. I don't think we have up to 2,000 past projects in our library here. Over 2,000 titles. So I created a Telegram channel where I uploaded all these books, and it's an open channel. Anybody can join. When you just type read thesis and dissertation library, it will come up. You can either join or you can flip through the table of contents. I will show you when I finish. I will take you through like some live demonstration. I created a table of content and pinned. So you can click on the table of content, look at the classification, look at what you are interested in. Is it water or environment? Then you press, and then it will take you to the exact, location where you can download whatever you want at any time. This I found very interesting. Then another one is mobile library. This one is textbooks. The first one is thesis and dissertation. This one is textbooks. Water resource and environmental engineering and all other engineering areas. All other engineering areas, as well as other non-engineering areas, science, business, economics, and all that. So it is my library that I thought of sharing with the world by creating this. It is a channel, an open one. Once you type mobile library, it will come up. It also has, the table of contents for your undergraduate programs, all the textbooks, the postgraduate, the specific areas, with over 50,000 titles. 50,000 titles. So this, I feel, probably is something that you can explore. But of course, like I told you, I have already linked you to the source for the books, the library genesis, isn't it? The library genesis. Like I told you, at the end, I will take you through the demonstration of the thesis and dissertation library and the mobile library. Getting the right resources can change the course of your research. it can change the course of your research. And for any meaningful research, you need to have the right tools to use. Articles, theses, dissertations, textbooks are some of the things you cannot do without. You cannot do without. Next.
Network is slow.
Mentorship. I indirectly started telling you about mentorship, which is very good research mindset. You need to identify a mentor. You need to have a very good mentor that will put you through. Someone that have gone through it, so that he will pave way, he will make things easier for you. Getting the resources also, like now when you check an article, you don't have subscription, you can make connections. Your friends that are abroad in other universities, please look at this. Or get me some good materials in this area based on your university subscription. You can have excellent resources. You have to establish the right connections. And you have to get good mentorship. I have told you about starting to write from your undergraduate project, isn't it? That was what I received. My greatest mentors here, Professor Bakr Ismail and Professor Johnson Otu. When I joined 2006, first thing, no, go back, your undergraduate project. Write an article out of it. I said, how can I? I started. Give it to them, they correct, strike this out, do, and then like that. Submit here, rejected, correct, submit there, rejected. That is the art of article writing. You have to imbibe, you have to start learning that art right from now. And before I finish my master's, I have some publication, which helped me even to get my PhD scholarship. Because I had some publications both locally and even in ISI journals. And that improves your chances of getting PhD scholarship anywhere in the world. So, no matter your work, no matter how you feel, I mean, it is not, it's of no consequence. I want to believe that there may be something that you can do about it, even if it's a conference paper. And getting the right mentor to put you through, especially in article writing, is very important, because article writing is different from writing your thesis. It's different, entirely different. It's a skill that you must learn from now on. You must learn from now on. Next. Now, another aspect, modeling. There may be probably non-engineering students here, I don't know. But even if there is, modeling is something that cuts across almost all areas. I started with modeling in psychology, isn't it? I told you about the big 5 personality models, which they use in predicting your personality, your mental health, your physical health, and all that. They are models, but psychology models. Modeling as engineering students, as water resource and environmental students, is very, very vital. Of course, this is an area that, you know, a lot of students are finding it very difficult. Yet, it is very critical to engineering discipline. A lot of times during presentation, you will see sometimes some guys doing things. When you ask them, I mean, what is engineering about it? You fail to find anything engineering. It appears just like pure science. Any scientist can do it. You have to separate or differentiate your research work from a pure science-based research. You have to demonstrate that this is an engineering research. How do you do that? By introducing modeling and optimization. These two key things are usually what differentiates a science-based, pure science-based research and an engineering research. Modeling and optimization. Very important. Very important. Of course, there are different types. You have the numerical modeling, statistical modeling, and artificial intelligence modeling. The famous one, artificial neural network. So selecting the correct predictive modeling technique is very, very important. Now, for numerical modeling, we use normally the finite element modeling, computational fluid dynamics,
using either MATLAB, Fluent, functional multiphysics, ModFlow, several, software. But of course, the numerical modeling is very strenuous. You have to connect, the processes analytically, mathematically, and all that. And then even when you have the software, because sometimes you may just solve the problems when you form the partial differential equations, you can write codes in MATLAB, in Mathematica, to solve the given problem, which is more difficult. Then you have some set of probably software that have incorporated maybe final element modeling, finite difference, different techniques of solving the PDEs that you can define your problems and they will solve it. Like the console multiphysics, like the ModFlow, the Fluent. So these are like less trainers. I remember when I was taking my PhD, students were introducing the console multiphysics, then the groundwater modeling, introducing to the ModFlow. So these are very important aspects. But then, like I said, this numerical modeling is, well, I say very complex. You need to have a very sound mathematical background. Unfortunately, in our mathematics that we take in the undergraduate, we don't take the partial differential. Probably, I think that is 541, probably which only electrical and mechanical take. I think it's Math 541, which we don't take. I don't know for now. So that would have to introduce us to the PDEs, to the numerical modeling aspect. But then, nevertheless, like I said, sometimes even your computer capacity may not be able to run the iterations because you need the result to converge, then you have problem with convergence and all that. Now, the less strenuous one, you have the statistical modeling, which is based on polynomial regression implemented in the response surface methodology. I think in 2015, I gave a workshop on how to use the design expert software in 2015 or so. I gave a workshop on how to use the response surface methodology in designing your experiment, in designing your work. It is less strenuous, yet its predictive capacity is very excellent, because modeling is all about prediction. It's all about understanding the process. The numerical modeling has some advantage because it relates the process. The statistical modeling may not bother about what actually takes place within the system. But then its predictive capacity is very excellent. May even be better than the numerical one. So the statistical modeling using the RSF is very, very good. You can model almost anything. Most especially in environmental engineering, in which you have to design your experiment ab initio. You have some variable that you want to test. You combine this, and that at different levels, and then conduct your experiments, then come and feed in your results. You optimize, you model. I found it very useful. I use numerical modeling during my PhD as well for directed research, where I model fluctuating water table. So I have good exposure in that area. Then I use the same PhD. I use the RSM also to model, because during the treatment processes, the variables. I told you about the electrokinetic remediation. You have different variables, voltage level, current. You have the electroosmotic flow. You have different things. So it's a very good material for modeling. When you are varying some variables, it allows you to design your experiment first. And then when you get results from those experiments, you feed into the software, and then you do a lot of excellent optimization and modeling using it. The last one is the AI model, the artificial intelligence. One of the best aspect of it is the artificial neural network. As we all know, artificial intelligence, you try to, feed in the data so that you teach the model how to be able to predict. And then once it understands the system, then it will be able to be producing the result, predicting your results. And it is very, very accurate. Now, why do I go through all these modeling techniques? Because like I told you, we have limited resources. We have limited resources. Nowadays, if you really want to do something great,
you need to go with the modeling. You have to incorporate some modeling and optimization aspect in your research. You have to find which one best fits your work. But of course, like I said, the AI, the ANN is a very promising one. Very promising one. And we have experts in this department. Dr. Jai is one of them. So you can learn it. And it will improve your work greatly. In one probably research, it can make you, publish a lot of papers. Once you have several, you just look at this and model it. And sometimes, even without going to lab, you can look at the existing data that you have, generate an ANN model that will be predicting a particular parameter. So it is very, very flexible and has a lot of significance in prediction, which is one of the central areas of any engineering project. So look at your work and explore which one best suits your area. Of course, I have given like the relative advantage and disadvantage of each one. But given our capacity and capability, the statistical modeling, the AI modeling are very, very promising tools that you can explore. And most of the software nowadays that we have, more often than not, you have what is called, let's say, the trial version. Because sometimes having the right software also is very critical. Yeah, but most of them now, like the design expert I know before, they give like trial period of up to 6 months. So of course, you can try it, and then within that period, if everything works fine, finish your work. Of course, you can have the money to buy the full version.